following is a Silver Bullion Television audiocast. Hello again, everyone, and welcome to another edition of Silver Bullion Television, SBTV. I'm your host, Patrick Vieira. Today we have with us Mr. John Petersen, whose diverse experience in corporate finance, natural resource development, and energy storage give him a unique and sometimes unsettling perspective on the technical, economic, and supply chain challenges facing the battery industry. Great to have you here today, John, and how are you doing?
I'm doing wonderfully, Patrick. Thank you for asking. It's good to be here. Thank you.
We're happy to have you. You've got quite some experience and knowledge in this field. So I'm hoping to devote a lot of time to electric vehicles, their projections, and the batteries that power them. I think you even coined the term Cobalt cliff.
Yes, sir. Yeah, I started looking at cobalt specifically as a challenged metal in early 2016. I was writing for writing for a financial blog aggregator that asked me to take a look at the three battery metals: cobalt, lithium, and graphite, because they were working with a bunch of junior miners. Lithium and graphite, I concluded, were not big problems, but I was shocked by the things I learned about cobalt. Most important one being is that nobody in the world produces cobalt as a primary metal. It's produced almost exclusively as a byproduct of copper mining in Africa and nickel mining in other parts of the world. And in every case, the cobalt is a fairly small fraction of the total metal value of the mines. And this byproduct nature is really massive. It's like 95% of the world's cobalt is produced as a byproduct.
Well, that's pretty substantial.
Yeah, it's huge. The big problem with the byproduct is that you can demand all you want of it, and unless the economics are good enough to move the needle for somebody who has a copper mine that produces a little bit of cobalt, that copper mine is not going to can't increase production. So cobalt, because it's a byproduct, cannot respond to normal laws of supply and demand. And you literally have to be able to justify going out and opening a new nickel and cobalt mine that's going to give you a little bit of cobalt that you're going to sell into a thirsty and hungry market, and it's going to give you a lot of nickel, which may very well depress the price of the nickel market. So your economics are very, very difficult.
Yeah, with the nickel, I understand it to be we have class 1 and class 2 nickel, where most of the nickel mine would be class 2, which would not be for the EVs. That would be the class 1. I hear that understand that the class 1 is a bit more it's not as plentiful as the class 2.
The over the last decade or so, the particularly Chinese stainless steel market, which is where the bulk of the world's nickel goes, has gone to a nickel pig iron production, where they have a deposit that is a good nickel content with a good iron content, and they just make a nickel pig iron that they can then go off and used to make stainless steel.
Okay.
To make nickel, or the mines that are more suitable for battery grade materials are the ones with a very low iron content. Those are the ones that are also likely to contain some cobalt. They're typically a laterite mine. At least, typically a laterite. But as I understand the numbers, global nickel is about 2.25 million tons a year, and 2/3 of that is nickel pig iron, and 1/3 of it is metal that could be used in batteries. So from a nickel perspective, it's not anywhere near as constrained as cobalt. It's not as dangerous a metal as cobalt is. But certainly there is a premium for nickel that can be used in batteries, because battery demand is ramping very rapidly.
I heard two words, cobalt and dangerous. Is that referring to the supply of cobalt?
Yeah, cobalt supplies are really, really strange. I did not fully understand the supply and demand dynamic in cobalt until early 2016, when I started researching it for somebody who wanted me to write on the three principal battery methods: lithium, cobalt, and graphite. For lithium and graphite, they're both primary products of mines. If you want a new lithium mine, you can go out and develop one. If you want a new graphite mine, you can go out and develop one. 95% of the world's cobalt, in comparison, is produced as a byproduct of copper in Africa or nickel elsewhere in the world. Less than 5% of the global supply of cobalt comes from primary cobalt mines. So that means that cobalt is a byproduct or a co-product of other metals.
Yes.
And increasing a cobalt price isn't enough to justify the opening of a new nickel mine or a new copper mine, until the combined economics of the nickel that's going to be produced in the mine, or the copper that's going to be produced in the mine, plus the cobalt that's going to be produced, justifies the expenditure. So unlike every other commodity you can think of, or most other commodities you can think of, cobalt will not respond to normal laws of supply and demand, whereas the price goes up, so will supply. Because from the supply side, cobalt supply doesn't increase unless the combined economics are good enough to pull along an underlying nickel or a copper mine.
Okay, so they're kind of intertwined. From the precious metal side, I think we sort of see the same thing with silver. A lot of silver comes from secondary mines, not primary miners. So I guess in that sense there is a bit of a similarity. But we do see quite a lot of people investing in cobalt. I think over the past couple of years it's gone up about 300% or so. Again, I would assume this is speculating quite a bit on EV vehicles coming into the marketplace. For instance, Volkswagen, they're projecting to have 1 million electric vehicles by 2025. And that's just Volkswagen. Will cobalt supply be able to hold up to meet this demand?
I don't believe so. I do not believe that terrestrial mining of cobalt is going to be sufficient for the anticipated growth of EVs. If you look at a low cobalt lithium-ion battery,
Mm-hmm.
like the NCA chemistry that Tesla uses, and has the lowest cobalt percentage out there. But
Okay.
even so, Tesla is requiring or using about 143 grams of cobalt per kilowatt hour of battery capacity.
Okay.
So a Model S with a 100 kilowatt battery needs 14 kilograms of cobalt. It's
Okay.
got to have it. You can't make the batteries without it. It's an absolutely essential metal, because while they're trying to maximize the nickel content of these battery materials,
Mm-hmm.
the cobalt stabilizes them. Nickel oxides without cobalt tend to be uh, they're prone to throw off lots of oxygen. They're prone to be unstable. And if you think about a lithium-ion cell, you have metal like nickel,
Mm-hmm.
or as a nickel oxide. The electrolyte is typically a hydrocarbon. Very fancy. It's typically a hydrocarbon.
Okay.
Separated is a hydrocarbon, and the typical anode is carbon powder. So if you think about a battery, if the cathode starts to outgas oxygen at low temperatures, then you have a source of a spark and the hydrocarbon and charcoal inside the sealed environment. And that is very explosive mixture.
Yeah, I was gonna say that sounds like a very bad day might be about to happen.
Yeah, it's called a bomb. Uh, quite,
Okay.
quite, quite literally, it is very explosive and very hazardous. The
Mm-hmm.
cobalt is what settles things down enough that they can use these things safely.
Okay.
And
Okay. Yeah, I wanted to ask you, since we're on this topic right now, could you help the listeners understand the terms that they hear, such as NCM 111, NCM 622, and now we're hearing quite a bit about NCM 811, which has to do with what you're talking about as far as part of the relationship between cobalt and nickel?
yeah, NCM is nickel, cobalt, manganese.
Okay.
And the 111, 523, 622, A11, there you're talking about the ratio of nickel to cobalt to manganese. So a 111 has equal amounts of nickel, cobalt, and manganese. They typically, in the chemical formulas, are typically lithium-2, nickel 1/3, cobalt 1/3, manganese 1/3, and then oxygen 2. So these are lithium mixed metal oxides.
Okay.
Although the ratios that you see in the NCM descriptors merely go to the relative content of nickel, cobalt, and manganese.
Okay.
NCM 111 was introduced in the mid-90s. It's been around for a very long time. 523 and 611 are pretty easy. They're both going into production now. They're not in there at high levels, but they're going into production, and they are less stable than the NCM 111. They tend to have thermal runaway problems at lower temperatures, and they tend to deteriorate more quickly
Okay.
than the 111. Everybody in the world is out there talking about NCM 811.
Yes.
The scientists I know think that NCM 811 is not going to be a thing for at least another 7 to 10 years, because it has stability problems, it has longevity problems, and it's extremely difficult to manufacture. To make an NCM 811, you have to do the manufacturing in an inert atmosphere. So what you're saving in cobalt cost, you are adding in other processing costs. Doing complex metallurgy in an inert atmosphere, dealing with mixed metal oxides is tough.
Yeah, that sounds like it potentially could be also a very bad day.
It's difficult. Nothing is impossible.
Mm-hmm.
But the battery industry it's like the world's worst industry in terms of its raw material dependence. If you look, for example, at a lead acid battery in your car, 70% of that battery weight is lead. That's what makes them really easy to recycle. If you look at a lithium-ion battery, about 40% of the cell weight, not the battery pack weight, about 40% of the cell weight is the cathode powder, the NCM or the NCA. So these mixed metal oxides are a huge percentage of, and it takes a lot. I mean, you're looking at 1.6 roughly kilograms of cathode powder to make a kilowatt hour of battery. So again, for your Tesla with a 100 kilowatt hour battery pack, it's 160 kilograms of cathode powder.
I mean, just looking at these NCM ratios, it seems like 1:1:1. Obviously, that looks like it would be the most stable. And what we're seeing is they're trying to push it to 8:1:1, and as you mentioned, there's some stability issues there. Is there anything else foreseeably on the near horizon that could take the place of a nickel, cobalt, manganese mixture?
Not that I can see. People have been talking about lithium sulfur and lithium air batteries for a very long time. The challenges of getting to a stable commercial product are very daunting. The battery industry is it's really wretched. We're used to we have been a spoiled generation where electronics go according to Moore's law. You have a 18-month cycle from a new product to an obsolete product.
Right.
In the battery industry, it takes a decade to go from a scientist in a laboratory saying "Eureka" to a first commercial product coming out of an automated factory run by guys wearing gimme caps. So yeah, there's a decade between Eureka and first product. There is another decade between first product and performance optimized product. There is yet one more decade between performance optimized product and cost optimized product, because this is all very heavy manufacturing. It's very materials intense. They're automating everything. You can walk into a lithium-ion battery plant with a machine gun and fire at random, and the odds are you wouldn't even come close to a human being.
Oh, that automated already, huh?
They are that automated, and it's amazing stuff to look at. But that means that it's also very difficult to reduce costs.
Mm-hmm.
And the story that we hear is battery prices are going to go down because of economies of scale.
Yes.
What people don't realize is that happens for a while, but as battery demands for raw materials increase beyond a certain point,
Mm-hmm.
prices of the materials go up. And when your raw materials represent 40% of the weight of the cell, and usually represent 60 to 70% of the cost in that cell, once the market grows to a point where it is having to pull new mineral sources into the equation to satisfy the demand, the price goes up, not down. And I think we have reached a point where lithium-ion battery prices are not going down anymore. I think they're going to turn and go the other direction, because the nickel price over the last couple of years is up, and it's up nicely. Lithium price over the last couple of years is up, and it's up nicely. And the cobalt price has gone from 10.50 to, what is it right now, $40 a pound?
Yeah, it's up there.
It's
Yeah,
huge.
yeah. Even the nickel, I think,
And
just within the
see
past.
anything?
Oh, sorry. Go ahead, John. Sorry.
I don't see anything likely to push that price in the other direction. Yes, there are two big cobalt projects coming online.
Mm-hmm.
Katanga, or Glencore, several years ago, shut down their Katanga mine in the Democratic Republic of Congo, so they could do a big mine upgrade and add cobalt circuits to it. So Glencore took the mine out of production for 3 years. They've just finished the upgrade, and they're just putting it back into production. So Katanga is going to add probably 30,000 tons of mine level cobalt per year. Another project that has been in the works for a very long time
Mm-hmm.
is the Brown Tailings Project, and it's being done by Eurasian Minerals. And that one, I think, starts to come on next year, and over a period of 2 or 3 years, it'll add another 20,000 tons of mine level.
Mm-hmm.
Well, and it's the reason I'm emphasizing mine level is, if you look at the production history of the world's mines and the world's refined cobalt production facilities,
Mm-hmm.
production is typically a third higher than refined metal production. So if mine production is 100%, refined metal production is in the 75% range, or 80%. You can see this in like the historical studies from the U.S. Geological Survey,
Mm-hmm.
where you look at mine production every year and refined metal production. There's a 25% shrinkage between what's produced at the mine and what comes out of the refinery as useful material. So there's a lot of loss between the mine and the refinery, and the gate of the refinery.
I think we're all seeing very big pushes by Audi, GM, Nissan, BMW, and again specifically, Volkswagen, who is spending billions on production plants and buying up future cobalt supplies. We're seeing China also making a big push with electric vehicles. Do you think that they're headed in the right direction?
I don't think they're headed in a possible direction.
Oh,
Right now,
interesting.
the world makes or produces about 100,000 tons of refined cobalt metal per year. Roughly half of that cobalt is used in irreplaceable industrial applications.
Okay.
You cannot make turbine blades for combustion turbine engines, jet engines, without cobalt for the high temperatures.
Yes.
Most high-speed steel, cutting steel, is a cobalt-based steel. When you look at carbide-tipped and diamond-tipped cutting tools,
Mm-hmm.
also it's everything from oil field drilling, drilling bits to saws in wood shops, cobalt is used as the cementing agent to hold the carbide tips to the steel tool. Cobalt is also essential in Fischer-Tropsch refining of coal and or natural gas to liquids. And it is essential in taking the sulfur out of diesel. These are cobalt catalysts, taking the sulfur out of diesel and making the PET plastic that we all drink from every day. All of those things absolutely have to have cobalt. And those industrial applications are 50,000 tons a year. The companies that are using it don't care what the cobalt price is. They have to have it,
Right.
or else they're in business. So that leaves 50,000 tons for the battery industry, plus whatever is whatever comes in a new supply, because the existing industrial uses they're not going to increase at rapid rates. Yes, they will increase slowly over time, but that's a pretty stable demand. If you look back over the last 10, 15 years, it's been a gradual couple of percent a year increase.
Right.
As more jet planes are made or whatever. It's not growing at huge rates. The growth rate has been in the battery industry, which was battery industry was growing just about the time that these African mines came online and started making way more cobalt than the world needed. So the battery industry for the last 10 years has had lots of access to cheap cobalt as mines that were brought on for copper started producing cobalt that nobody needed. So the battery industry said, "Heck, we'll give you $10 a pound for it, and you'll be grateful for it." So the battery industry was in a very it was a beneficiary of something that wasn't caused by battery industry demand. The cobalt supply increased because copper mines were coming back online in the DRC after years of political strife and war. So, peace breaks out in the Congo. The world has too much cobalt. The only people that want more cobalt are the battery industry. So the battery industry benefits.
Right.
That's not going to happen once we get these two big projects in the DRC online over the next couple of years. Once Katanga is in at full production and Roan is in at full production, there's going to be another 50,000 tons a year of cobalt metal and cobalt ore, and probably 38,000 tons a year of cobalt metal.
I guess it's also interesting when I look at again these automakers who are spending so much money building factories to produce the EVs. They're not going to want to let these factories sit idle, and they are more than likely going to be paying any price for cobalt.
I think so, and that's scary. Either that, or they're going to throw their hands up and say to the politicians, "Guys, if you want me to make these, find me the metals. Government, find me the cobalt to do this."
The U.S., we classify cobalt as a strategic metal, correct?
Oh yeah, well, it's been a strategic metal for a long time.
Okay.
And it's getting more and more strategic, because you can't You can't make jet engines without it. You
Yes.
can't make gas turbine generators without it.
Yeah. Even
You,
in this part of the world, that China's also made cobalt strategic metal as well.
well, and that takes you to the other half of the equation. As earlier, I was telling you that the world's cobalt supply right now is 50% industrial applications, 50% batteries, and
Yes.
that's just close enough for the spitball. Uh, if you look at where the cobalt is refined, it's not quite 50-50 because China is more than 50%, but it's basically 50% of the world's cobalt is refined in China,
Hmm.
and 50% of the world's cobalt is refined in not China. So you have China is in control of 50% of the world's cobalt.
Yes.
Everybody else is in control of 50%. Now, if you look at how the cobalt produced in China is used, about 20% of the Chinese cobalt, call it 10,000 tons, is used for industrial applications, and the other 80% of Chinese cobalt, call it 80,000 or 40,000 tons,
Hmm.
is used in batteries. That means when you get to the non-China cobalt, uh, China has produced 10,000 tons of cobalt for industrial applications. There is 40,000 tons of cobalt that has to be used, or 50,000 tons that has to be used globally
Hmm.
for industrial applications. So in the cobalt not refined in China, 40,000 tons of that has to go to industrial applications.
Yes. Yes.
And only 10,000 tons of not China cobalt is available to the battery industry.
Yeah, and I suppose this is why we see China so far ahead as far as EVs go.
Yeah, and in China, it's more a political situation than an environmental one. They're trying to do anything they can to improve the air quality in these mega cities.
Hmm.
Uh, and if you can move the exhaust from cars 100 miles out of town and put it in a power plant somewhere, that's a success if you're a politician in China.
Besides environmental, yeah, I do think it's political. I mean, I think China's grown so much, and they surely are looking to be a world leader in a few different areas, and EVs
Yeah,
looks to be one of them.
it's political. They're uh, looking to change the way people are living. E-bikes in China are apparently uh, a massive phenomenon, and I think they're a very good use of lithium-ion batteries. I don't think that, frankly, I don't think that an automobile is a good use of battery, because if you have an electric bike, for example, and they typically are 500 to 750 kilowatts or watt hours of battery capacity.
Hmm.
So call it a kilowatt hour just to make the math easy. You can make 100 e-bikes with the batteries that go into one Tesla.
Well, yeah.
I would submit that from the perspective of aggregate human benefit,
Hmm.
the aggregate human benefit of 100 e-bikes just beats the pants off of the benefit of one Tesla. You,
That's
know,
a good
you,
point. That's a good point, John.
you give 100 people mobility instead of one, that's a winner in my book.
Yeah, that's a good point, John. It's been a pleasure speaking with you. You've gave us some really good insight on cobalt, nickel, battery, the engineering of batteries. Could you please share with our listeners how they can find more of your work and follow you?
Okay, I have been publishing for years as a contributor to Seeking Alpha.
Yes.
So if you go to Seeking Alpha and type in John Petersen, Petersen, you'll get my entire archive. I have started contributing to a website called Metal and Mining Pundits. It's miningpundits.com.
Okay.
And the miningpundits.com has a complete archive of my early work on Cobalt.
It's really interesting to talk with you because, as I had mentioned before, so-called pre-interview, let's say, we are a precious metals business, silver and gold, and then the market did shade over into crypto, so we had to adapt. And then also we recently started going into physical cobalt and physical nickel. So we're just trying.
I would like you to tell me about the physical cobalt, because one of the big sadnesses of my life is that I haven't found a good way that I would feel comfortable investing in cobalt. But knowing that it's possible to have a 250 kilogram barrel of cobalt sitting in your warehouse, I'd be curious to know, in terms of purchase pricing, how close do you get to spot price? In terms of annual warehousing charges, what do they run? I personally would like to know more about what you're doing.
What we're doing, John? Well, we're actually selling these metals that you're talking about, the cobalt and the nickel. But for our viewers, our guests, you'd have to head on over to our website, www.silverbullion.com.sg, and go ahead and click on electric vehicle metals and learn more about it.
This has been a lot of fun. I really appreciate the time that you've taken with me, and let's do it again.
I'd absolutely like to do it again. I think you're the go-to battery guy for sure. That was John Petersen of miningpundits.com sharing with us his insights on EV metals, cobalt, and nickel. To find out more about John's work, please visit his website, miningpundits.com. And if you like this video, please hit the like button and subscribe to the SBTV channel to be updated on new content.